This video is finishing up graphing absolute value functions. We just spent some time looking at all of the different transformations that we can perform on an absolute value function. If I have a negative in front, it reflects my graph down. If I have an a value greater than 1 in front, it stretches the graph vertically. If it's equal to 1, it's just a standard V shape. If it's between 0 and 1, it's a vertical compression. Our graph gets shorter of the y values. Any h value on the inside, if it's positive, it moves my graph to the left. If it's negative, it moves my graph to the right. And k values, we can either add on to the end and move the graph up, or if it's a negative, we would move the graph down. Putting these all together, we're now actually going to go ahead and try to graph some absolute values by hand, and then apply and the characteristics that we learned in topic 2, y-intercept, domain, range, zeros, to what we see. So the process for graphing is actually very much like identifying the transformations using A, H, and K. So we're going to start off by identifying our H and K and writing it as an ordered pair. This HK is known as our vertex. It is the most important and critical point that we graph. So looking at our equation, I see that my H value is -4, and I see that my K value is -3. But the way we write it is not as -4, -3. We must write it as +4, -3. Remember, the H value is the opposite of what we see. So we see it as -4, but we must interpret it as a +4 from our transformations. So graphing this for -3, I've graphed my vertex. The next step is to identify and use our A value. And this A value is going to act as our slope for absolute value functions. Or really what we're doing is we're changing the y's. I use slopes in parentheses and quotations here because it's not actually slope, but since we're doing an absolute value function and it's a straight, has 2 straight pieces, we're going to use it as slope just to help us get along. So our A value here is going to be 2, or you can think about it as 2 over 1. So from my vertex, I'm going to go up 2 and over 1, up 2 and over 1 to get one side of my absolute value function. And then I'm going to do a mirror image of this. I'm going to go up 2 and back 1, up 2 and back 1, up 2, back 1, up 2, back 1 to get the other side of my absolute value function. And there we go. So notice again we have a slope going to the right, and since we know the V is a mirror image down through the vertex, we can go ahead and use this idea of quote-unquote slope to help us get the shape of the graph. Okay, let's take a look at R here. Identifying HK first, and graph our HK is at -2, +1, -2, +1. So from there, once I've graphed my vertex, I'm going to go ahead and use this idea of slope for the A value, which in this case is -1. Now the A value here is 1, but the negative we're going to tack with it, meaning that it should be a reflection down. So it means for my slope, I'm going to go down 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1 to get 1/2 of the absolute value function. And then since it's a mirror image, I'm going to go down 1, back 1, down 1, back 1, down 1, back 1 for my slope to get the other portion of my absolute value function. So that's it. Graph HK, use the slope to get the V shape for the right, and then we use mirror image for the left. Take a moment and try S. Pause the video and try that out. We should see HK at -3, -2, and an A value of 1/2. So my vertex is at -3, -2. My slope up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, and then the mirror image up 1, back 2, up 1, back 2 to get my other points. And we have a very, very short or vertically compressed absolute value function. From here, we should be able to go ahead and identify all of our key characteristics for each graph. Y-intercepts where it's across the y-axis, zeros, another word for x-intercepts, domain, range, increasing, and end behavior. Take a moment and see if you can fill those out. Pause the video and give it a try. Here is all the key information. A couple things to note. My zeros, sometimes we have to approximate them. Here I needed to continue my graph over a little bit more to get -7, 0. Domain in each of these was -infinity to +infinity. Range, again, how far down to how far up the graph goes. We use a hard bracket. For increasing and decreasing intervals, we're again looking and labeling them in terms of their x values, and we're always using parentheses. End behavior, what's the graph doing as I go towards negative and positive infinity? What are the y values doing as is how we're actually answering each of these. What are the y values doing? Hopefully those were correct. We're now going to go ahead and take a moment, and you're going to do two things. You're first going to go to Desmos. and you're going to use this code to enter into an activity where we're going to go ahead and we're going to graph some absolute value functions. Graphing various absolute value functions, there's 9 problems for you to do that'll tell you whether you're right or wrong, after which you're going to go on to Khan Academy and do graph absolute value functions from Khan Academy, which is listed there. So once again, looking at the code, start here for student Desmos and then move to the Khan Academy.